nilpatente radical. Uh, Let A be associative algebra for any elements A, B, C belongs to A. The equality A, B, C is equal to A, B, C holds. Consider the following sequence of subspace of algebra A. A1 is equal to A2 is equal to A1 multiplied by A, and so on. A I plus 1 is equal to A I multiplied A. It's easy to verify that is associative algebra is a product of two-side ideals is a two-side ideal contained in their intersection. Uh, Therefore, its subspace I is an ideal in A and is contained in A I minus 1. Minus 1.
But you have to prove that the product of two ideals will be another one ideal.
Uh, yes. Uh,
How
uh,
you will prove it?
Next passage'larda bor da, keyingi sahifalarda bor da isboti.
Sure.
Следующем.
In the next
э,
page, you
да.
will show, yes?
Hmm.
Okay.
No, it's not good. It was written that it is easy to verify, but when you have to verify directly after the said that it is easy to verify.
Ну, сейчас все путают он.
Ну, of course, путает,
Mhm.
но как
А?
бы, да, конечно, путает, но надо же как бы культуру математическую сразу прививать. Ну, что он говорит, легко проверить, а когда проверит? В конце дня, вот, например,
Hmm.
спросим, например, кого, вот, например, вот Зухида, например, для нее легко понять, что продукт двух идеалов– это идеал.
Let's prove the case two side ideals, the product of two-side ideal. Let us
Yes.
A and J two-side ideals of A.
Aski Azi,
Uh,
Manaba. Söyledim, pasta bana
uh,
okuyacağız bak. Şirket spotlight.
A and J two-side ideal of A.
Okay.
Uh, A product J uh, uh,
You have to
is
prove that E product J also two-sided ideal.
ideal. Uh, any element A is AJ and any
Okay.
element B in A.
From the algebra. Okay.
Uh, A multiplied by uh, is A belong to I multiplied J. Uh, so X multiplied Y is X
Hmm.
in A, Y
Hmm.
in AJ.
Okay.
Okay, multiplied by is uh, by associative.
By
Y
associativity
multiplied
X, Y. Okay.
by ideal J is belong to J.
Yes.
Uh, so
It's
A
belong to
multiplied J.
E, A, J. Okay.
Hmm. Bu düşünde bu kuvvetli
Now
yani.
we have considered BA,
Hı. V A is equal to uh,
B,
B
B, X, Y,
X Y
and
by
again you will use
associative B
associativity,
BX Y.
BX, Y. BX
E
belongs to
belongs to
E,
EJ because
Y
I
belongs to J.
ideal of A.
Okay.
Okay.
Yes.
Mhm. Definition one, an element A of an algebra is called nilpotent if uh, A to the power of n is equal to 0 for some natural number n. Definition 2, an algebra A called nil algebra if each of its elements is nilpotent. Definition 3, an algebra A is called nilpotent if A is to the power of n is equal to 0 for some natural number. Okay. Proposition 1, an associative algebra A is nilpotent if only if it's solvable. Prof.
And
The
what is
from
solvable?
definition. Uh,
It means solvable.
uh, uh, Consider the subspace of A bracket 1 as A bracket 2 is equal to A bracket 1 multiplied A bracket 1 and so on, and bracket, sorry, bracket n plus 1 is equal to n multiplied A bracket n. Okay. Uh, uh, is algebra A solvable if uh, A power to the power of bracket n 0 is equal to 0, some natural number n 0. Okay.
А вот где вы это пишете, вот точка, это что такое? Это умножение внутри пространства или это минус? Что это?
No, not точка.
Sorry, what is this? Yeah, I'm sorry. Yeah, this is a dot. Okay.
Еще дот.
So that is multiplication.
Yeah, okay, thank you.
Okay. Shall I continue?
Uh, what uh, uh, what about the nilpotency? You gave the definition, yes?
Hmm.
Okay.
From the definition of subspace in the concentric chains, we have A bracket I subset of I plus 1. The one
Why? Show
nilpotency
it. Show it. So I didn't.
Hmm.
Why this is true? Show it us.
uh, A bracket 1 is
It's a
A bracket 2 is A multiplied A.
okay.
Is A 2.
Yes.
A multiplied 3 is A 2 multiplied A 2. This is A square, subset of uh, A square multiplied A. This is A3. Oh, sorry.
Is it a
I am sorry.
definition of nilpotence? Because I thought it should be not dots but squares. No?
Hmm.
I am sorry. So I didn't. A2
Hmm.
equal to A2.
Hmm.
But you have to prove that A2 belongs to A3. If you consider this.
Sorry. Hmm.
That's why I'm confused. So
That's right.
I don't know if this is right or not. Now, by
Uh-huh.
induction, you will prove that AI belongs to AIS.
Huh.
Maybe
Sorry.
here consider it a
Sorry.
1 is equal to a times to a.
Uh,
For maybe
No,
for that reason.
I don't know how, but here Surgeon should give exact definition. What is a and what is a bracket I?
mm,
You should give exact definition. What is this? What is it? After then, you will prove the proposition. Okay?
okay. Hmm. Please very again.
So again, what is no here? You may type here. What is AI
Hmm.
and what is AI? Just give a definition here, okay?
Hmm.
2 lines. Let's give it. Mahmut uçurayım tepene. Sözden.
Hmm.
Tepege yaz koyun. Ay. İğnemeydi, a kolşitli iğnemeydi. Yaz koyun. Tepege çağırlı kadar. Bu şeylerden
Hmm.
yazayım. Sözden.
Hmm.
Ben nege bu şeyden başladım.
Hmm.
Az yaz yapsın da uçuruyor. Yaz yapsın da uçuruyor. Doskeden. Правильно надо воспользоваться вместе.
A minus 1 multiplied A.
Окей?
A bracket I is I minus 1 bracket multiplied
Окей.
A I minus 1
I
bracket.
minus one. Okay. Now you know that this is true, yes?
Hmm.
This here is I. Okay, let's continue.
Sorry. This case A bracket 1 is A square. A bracket 2 is A 1 multiplied
Mm.
A bracket 1. Sorry.
And so on, yes?
Hmm.
Ah. Then there E plus one, yes?
Hmm. Uh,
Okay.
that's right. Okay.
Okay.
Hmm.
So
Hmm.
next.
Using the associative of multiplication, it's easy to prove by induction that uh, a bracket I is equal to a to 2 to the power of I.
Let's prove it now.
Hmm? Is E1
Okay.
is bracket a square by definition. Okay.
A1 is A square by definition. Okay.
uh,
And A2.
in A2, a bracket 2 is by
Mm.
definition A1, multiply A1. This is a square, multiply a square. This is A3 and A1. Why associative? This
Now,
is
here you will use
A4.
the associativity, yes? Here.
A square multiplied A. This
Uh,
is A square A multiplied A.
okay. Then,
And so on. Uh, suppose A bracket I to the power of A. And,
yes.
oh, sorry. Uh, A I plus 1. By definition, I multiplied A bracket I. This is by induction. Suppose
Mhm.
I multiplied to I.
Okay.
Many times by definition, A 2 powers of I plus 1. Okay?
I didn't understand. Many times of what?
Sorry. Uh,
Induction.
uh,
Hypothesis.
hmm.
Again, you will use associativity.
Association.
Okay.
Okay? Hmm.
Mm. So the nilpotency and the solvability for the associative algebras are same,
Say
yes?
again. Yes.
Okay.
Proposition 2. A finite sum of the left nilpotent ideals is a left nilpotent ideal.
Mm.
Proof. The only natural fact in the state proposition is the nilpotency of the sum of ideals of A. An obvious induction reduces the statement to the case of two ideals. Okay, let A and J, let I and J be left nilpotent ideals of A. That's A to the power n is equal to 0. J to the power of m is equal to 0 for some natural number n and m. Then I plus j to the power of n plus m is equal to 0. Indeed, the first note that uh, I plus j to the power of n plus m is equal to sum uh, this by binamal formdan da where
Binomial form.
binomial form. Thank you. Where sum of I is equal to 1 to s I plus rj is equal to m plus m. Moreover, that to the inclusion A is subset of is because I left ideal of A. Okay. These multiplications subset of A to the power of K multiply J to the power of RS.
Should
Okay.
should you explain this some with some simple example? Oddiy misolda bitta o'shani tushuntirib bera olasizmi?
Ha.
Yes, for example, n plus m equal to 4 or 5.
Yes.
Hmm. Uh,
N equal to 2, m equal to 3, for example.
Only this relation.
hmm. Shuni o'zini tushuntirib bera qolay.
Ha,
Quyidagicha guruhlab chiqamizda. R1, A, K2, JR2 multiply A, K3. Okay? And so on. J, R, RS minus 1 multiplied E, K, S multiplied J, RS. Subset of this subset of by ideal I K2. Okay, this subset of mhm, 3E.
Doğru. İdiot adamlar.
GM idiot adamsın.
I K1, I K2, and so on. I K S. This is I K J R S, where K sum K I. Okay.
yes, I understand.
Okay, is it clear for everyone? Nigola, for example.
Ha. Boya
Did you
ideological.
understand the proof of proposition? Nigola,
Да.
Mahbat,
Yo, tushundim keyin ustoz.
is it clear for you? What does it mean with this one, for example? What
Yes,
is it?
yes, clever. I think
Okay.
that AIS degree, S degree, subset of IS.
Now, for
Why?
example, if we consider I plus G on the power 5, for example, yes?
Yes.
Mhm.
5, okay. For example, n equal to 2, m equal to 3, yes? For example.
Yes.
Mhm.
What does it mean? It means E5 plus E4 G E
G1.
plus, for example, E3, for example, G,
G2.
then E2,
E2, yes.
okay? Plus and
Mhm.
so on. For example, G2,
Two.
E, for example, G.
Mm,
Plus the sum of the powers should be equal to 5, okay?
Okay.
mhm. So
And
all
he
of
said
them,
that,
yeah.
uh,
So all of them elements, subset of I think.
for, no, not all of them, because in the last,
Uh-huh.
we obtain G on the power 5.
Mhm.
Not all of them. But
Okay.
we have that n equal to 2, m equal to 3. What does it mean? It means e squared equal to 0,
Mhm.
g on the power 3 equal to 0, yes?
Mm. Mhm.
Since g equal to e squared equal to 0, this is 0, okay?
Mhm.
This is also 0, okay?
Yes.
Why this is 0? For example, this one.
There we may take. or you may use associative.
Oh, we will use
Then,
associativity then.
you can write e square, I square,
Hmm.
I square.
How
It is
you?
equal 0.
No, after the associativity, how you can write as a e square? After the
So,
associativity, you shouldn't write as a e square
J
and
is 3 degree. We should write
no.
or
This is we use that is ideal.
uh-huh.
E multiply something, G or G square, it doesn't matter, belongs to
Uh-huh.
E.
Yes.
This is E
This
square equal to 0.
from this we take.
Yeah,
Okay.
here we will use E
Uh-huh.
is ideal. For
Yes.
example, if you have like this E, for example, G square,
Mm-hmm.
E, after then G square,
Mm-hmm.
you will have such type of element. You will use the G is an ideal. And G on the power 3 equal to 0. Okay?
Mm-hmm. Okay.
That's why all elements are equal to 0. So I plus G equal to 0. I
Mm-hmm.
plus G on the power 5 equal to 0. And similarly for any N and M.
Mm,
Okay?
yes. Research. It's clever.
Ursana,
Clever, clever. Yes.
Yes,
did you
I
get it?
understand.
Okay. Next.
If k greater than or equal to n, then the last product equals to 0. Always uh, sum rj greater than or equals to m, and using the equation a chi I chi 1 multiplied j r1 I chi 2 multiplied and so on, uh, a uh, k ks minus 1 sorry j uh, rs minus 1 multiplied j rs minus 1 multiplied a s multiplied j rs subset of a chi 1 multiplied j r, where r the sum r j.
Why
Okay.
I degree K2 begin with 2, not 1?
uh, Sorry, repeat.
There you write K1
uh,
multiplication GR1 multiplication I K2.
uh,
Why
uh,
K2, not 1?
because j for r1 a k2 subset of jr1
R1
by
subset.
But it is just explanation of I explained you E and something. After then, for example, G square E G, yes?
Mhm.
If the number of G more than 3, the number of G more than 3, you will use that G is important. If the
Mhm.
number of G less than 3, then the number of E more than 2. Then you will use that E is important.
Mhm.
He's trying to explain this one. There's K1, L1, K2, L2, and so on. If in the number of the sum of K1, K2, and Ks more than K, then we will use that is important.
Mhm.
If the sum of K1, K2, and so on Ks less than K, less than N, then we obtain that the sum of R1, R2, and Rs more than M.
Mhm.
Then we will use that G is important. That's all.
Uh,
Okay?
okay. Mm-hmm. Yeah, we watch this condition. So.
Yeah.
Mm.
We again obtain that the product, this product equals 0. The above reasons
Okay.
explanations the nilpotence
I
of
think
ideal.
everyone is understand this one. You may continue. So, next.
Mhm. Theorem, Van Neumann theorem. Finite dimensional associative algebra A is a nilpotent if and only if every element of A is nilpotent. Okay.
What does it mean? Element is important.
Hmm?
What does it mean? Element is important.
Uh, Definition 1, by definition 1, an
Yes.
element nilpotent if A to the power of n is equal to 0 for
Okay.
natural number n.
Okay.
I disagree.
Okay.
Proof, if A is nilpotent, that's A to the power of n is equal to 0 for some n. Then A to the power of n is equal to for any element A in uh, A. Okay?
Yeah, this is clear.
Hmm.
This is clear. We more interesting with the conversely.
Mm-hmm. Assume that for each element A, the x is a natural number n depend on A such that uh, A to the power of n is equal to 0. We prove the nilpotency of the algebra A by induction on its dimension. Okay?
Mm,
If dim A is equal to 1,
okay.
uh, A span A. Then A nilpotent, this is A square is 0. So
Okay, it's
A
okay for
nilpotent.
one dimension. It's okay.
Because for any element
And not a
A,
square. A on the
Some
power n equal to 0.
okay, sorry,
A on
A
the
to the
power n
power.
equal to 0.
Okay,
It means for the
uh,
algebra also A
hmm,
on the power n equal to 0
uh,
because A contains is just one basic element. A is a
uh,
basic element for the algebra.
right, sorry.
So for
Hmm,
this reason, for the one dimensional case, it's okay.
hmm.
No problem.
Uh,
So
Suppose that for any algebra of dimension less than m, the statement of the theorem holds. Consider
yes.
an algebra A of dimension m.
Mm.
Uh, uh, l- let's say two case.
Hmm.
Uh, First case, a square uh, isn't to the a equal to
Is not equal to A.
a.
Okay.
Uh, Second case, a square is uh, equal to the a. Okay.
Okay.
First case, then the subalgebra uh, a square is nilpotent because
Mhm.
uh, dim 2
Less than N.
less than n. Okay.
Okay.
Then a to the power of 2s is equal to 0. That's a is nilpotent algebra.
No,
Okay.
just wait. I didn't
What?
understand this part.
Uh, uh, this clear.
Mm.
Then a square multiplied a square square times s. Okay.
Yeah, it's equal to 0.
And this is equal to 0. Boshqa tomondan quyidagi tengda assosiativlikdan foydalansak, bir safar
You use
bittani
the
bittani
associativity,
kiritib,
yes?
ikki s ham shunga tengligini isbotlasak bo'ladi.
So A square, for example.
Hmm. Is
A
equal to
square, A
a.
square. No, 3A square, for example, yes? You will use the associativity and you will obtain A,
Hmm.
then A, like this.
Hmm.
A, and so on, 6 times, yes?
Hmm.
A and A, yes? It means it's just A, what? 6, yes?
Yes.
Actually, A square, it is A square, A, 2
Hmm.
2 yes?
Hmm. Yes.
But since I is in associative algebra,
Hmm.
this equality is hold. That's why you should use this one, yes?
Hmm.
Okay.
Uh, Let
So
us show. Hmm.
let's back, Surajdan.
Hmm.
So this case is clear for everyone.
Yeah.
Makbal,
No,
Sonal,
no. For me,
Clear for
it's
me.
when A
not
square
clear
is not
when.
equal to A,
Where is?
he
Please repeat.
Contact with element in last one.
what, Sonal?
Element bilan bog'liqligini tushunmadim oxirgisini. Ha, elementga bog'liqligini ko'rsatyapmiz-ku, hozir isbotlash kerak-ku.
Qaysini?
Oxirgisida.
Mana a kvadrat a ga teng bo'lmasa, u holda tabiiyki a kvadratning o'lchami a dan kichik.
Aha.
Induksiya faraziga ko'ra, demak a kvadrat algebramiz nilpotent. U uchun shunday bir s topiladiki, uning s'inchi darajasi 0 bo'ladi. To'g'rimi? Va ko'rsatdikki a
Kvadrat holatni ko'ryapmiz faqat. Aha.
0, u boshqa tomondan esa a 2s ga teng dedik. Demak, a algebra uchun shunday son, natural son topib ko'rsatdikki, a ning
Nolga
shuncha
teng bo'lishi
darajasi
kerak.
0 bo'ldi. Demak,
Ha,
a ning
bo'ldi.
o'zi ham nilpotentlik kelib chiqar ekan, agar mana shu holat bo'lsa. Endi
Hmm.
umuman olganda a kvadrat a ga teng bo'la olmasligini isbotlasak,
Shoshilma. Shoshib ketmada. Hamma hazil qilyapsan A kvadrat teng emas A'ni. To'xta, o'chirib tur A kvadratni A'ni.
mhm,
O'chirib tur. Всем понятно, да? А квадрат, когда А квадрат отличный от А, доказал, что I is nilpotent. Is it
Да.
clear for everyone?
Yes.
Yes.
Akbar?
Mm, I think that if a square not equal a, dimension square subset
The dimension of a square is less than the dimension of A.
yes. Why this?
Uh, by the assumption of induction,
Mm.
by the assumption of induction, if an algebra has a dimension of less than n, then from the nilpotency of element, we obtain the nilpotency of algebra.
They're given.
Ah,
Yes.
what is it in induction? What does it mean induction? Makbar.
Induction.
The, yes. What does it mean induction?
Induksiya metodiga ko'ra ko'ryapmiz-da.
Induksiya
Induksiya.
metodi nima degani u? Qanaqa bir?
And thing. Firstly, we show n equal to 1. Then
Okay.
we suppose
Well,
that
he
n
showed
is,
m equal to 1. Then we'll suppose what?
suppose m equal m, I think. M
Suppose
equal
that
uh-huh,
if
less
m
than m, less than
less
m. Yes,
than k, it is okay, yes?
yes.
And we will show that m equal to n, yes?
Mm-hmm.
He showed first m equal to 1. Then he
Uh-huh.
supposed that less than m is okay.
Yes.
He will like to show for the m. That's why since a square is not equal to n, the dimension of a square less than n. So for
Yes.
a square is true. That's why a square is important.
Yes. Yes. Yes. Yes.
A square is
I
important. It
understood.
means a square on the power s equal to 0 for some s.
Mm-hmm.
But due to associativity, we obtain a2 on the power s equal to a to
There.
s.
It was, yes, it
And
is
a
equal
to
to
s
0.
is 0 is meant, it means that a is important.
Nilpotent algebra is.
A is important. Okay?
Yes. Yes. Yes. No, I understood.
Okay. And now we will consider the case a square is equal to a. Let's continue, Sajda.
Mhm.
Next page.
Mhm.
Next
Uh,
page.
let us let us show that the case a square is equal to a is impossible. Okay.
Okay, uh, we want to obtain the contradiction, yes?
Hmm.
In this case. Okay, show
Uh,
it.
Fix some basis of a, e1, e2, and so on, em of the algebra A. Then a square is equal to a e1 plus a e2 plus and so on a em. Okay? Ya'ni shu ikkita to'plamni tengligini ko'rsatish qiyin emas. If a is equal to a
Why?
square,
Why these
hmm,
two sets equal?
chunki bundan ixtiyoriy element olsak bu ko'rinishda bundan ixtiyoriy element e, olib bunda yotishini, ya'ni a kvadrat bunga qism ekanini, boshqa tarafdan esa a y1 a y2 plus va hokazo a ym ni a kvadratga qism ekanini ko'rsatsa bo'ladi. Bundan esa shu ikkalasi tenglik kelib chiqadi. Mana ixtiyoriy bundan bir element
Yes, yes.
olsak,
We have this condition. We have from this, yes. A square equal a, then the two subsets equal.
hmm.
Okay.
If A is equal to A square, then the algebra A is a finite sum of left ideals A, E, I. Okay? And suppose all these ideals are proper. Then
Why
by
this is left ideal?
because any element A in AIE, and then any element by A ya ideal ve geometriyen A teknik B multiplet X A E then by associative. Okay.
Yes, yes.
Mhm. Suppose all these ideals are proper, then by induction hypothesis each ideal AEI is nilpotent.
What does it mean proper?
Uh, mm, bunday deganida A, Y, I aynan A bilan ismi tushib qolmasin demoqchi.
Shuni
Ya'ni
ayting, ringnichalab.
A EI isn't equal to A. This means that then by induction hypothesis each ideal AIE is nilpotent. Applying proposition 2 we obtain the nilpotence of algebra A in particular a square subset of A, which contradiction is subsumption.
Actually, I didn't understand the last statement, last one.
Mhm.
Why applying proposition 2, we obtain the nilpotence of the algebra A. What is it, proposition 2?
Mana endi bular ideal ekanku A, Y'lar. Shuning uchun ularning
Yes.
yig'indisi ham idealligini proposition 2 dan olyapti. Demak, e, A kvadrat A ga tengligidan A nilpotent algebra ekani kelib chiqadi. Bu esa mm, bunga zidda. Sababi A kvadrat A nilpotent bo'lsa, u holda A kvadrat bu yana A ga teng bo'ladi. A ning kubi ham A ga teng bo'lib qoladi. Bu
Tushunarli.
hech
Maqbal, Xursanoy, Nigora, did you understand?
Да, понятно.
Да, да,
Huh?
да,
Всем
Понятно?
понятно, да?
Да.
да.
Yes.
Ну, Мақбал, можете повторить, объяснить на русском языке? Объясните, пожалуйста, вот эту часть.
На русском?
На русском, да, вот эту часть.
М,
Сложно. Учили хамерса?
М, м,
Сложно, да. Вот это сейчас объясните.
а, Так.
Или кто? Хурсаной?
Так. First,
Мы рассматриваем случай а квадрат равно а.
Да.
И он дал такой базис e1 до em,
Да.
такой базис для алгебры. Потом а квадрат мы напишем с этим, потому что так как а это умноженное а, мы можем написать как а умноженное на каждый базис с proposition 2. Он так сказал, я так поняла.
Кто?
Потом, если у нас а равен а на квадрат, тогда алгебра А, так, find окончательная
Конечная сумма.
сумма, конечная
Мгм.
сумма левых идеалов А и
М.
здесь и от единицы до m будет идеалом. А пропер это означало, что если вот А, Е, И не равна на А.
Да.
Так. Мы это уже тогда, это по индукции гипотеза, каждый
Мгм.
идеал А, Е, И будет нилпотентом. Потому что
Мгм.
мы выше в proposition 2 этого рассмотрели, что
Мгм.
по индукции это А и у нас был идеал, и мы
Мгм.
получаем, что алгебра А у нас нилпотент.
Мгм.
В отдельном случае, если А квадрат принадлежит на А,
Мгм.
у нас появляется противоречие к нашему гипотезу.
Ну да, на самом деле мы хотели доказать, что А нильпотентный, но и доказали, да? То есть каждый А и нильпотентный,
Да,
а и сумма, то есть сумма двух нильпотентных идеалов опять нильпотентными доказали, да? Поэтому
да.
сумма некоторых m-тех нильпотентных идеалов тоже нильпотентна, то есть м, А квадрат нильпотентна и А сама тоже нильпотентна, да?
Мы думали, что невозможно, но получилось возможно.
Да,
Вот такой
противоречие.
да.
Понятно, да? Сэм. Но у меня есть вопрос. Сложный. Вы доказали, что вот этот АИ left идеал.
М,
Но не доказали, что это двусторонний идеал. А здесь
Пардон.
типа вот АИ просто идеал пишите, не left идеал. Типа вот используете то, что для двусторонних идеалов доказали. Proposition 2 вы доказали для двусторонних идеалов. А почему можно это, когда вот сказали, что только левый идеал, только left идеал? А почему можно опять proposition 2 использовать? Поняли, нет?
Left input. Bu
Так,
har doim ham
я
o'ylab tushunmay
По-моему,
qoldim.
там тоже
O'ylab
left
savolingizga.
написано, да?
Там тоже left был,
Preposition.
да? Покажите
Да,
тогда.
да. В preposition.
Покажите тогда вот
Preposition
этот
ikkining
proposition.
ko'rsating.
Да.
Left. Патент идеал.
Left, да?
М.
Ну хорошо. Тогда вопросов нет.
вот
Дальше.
у меня хоть немножко, я не поняла, почему мы представляем такой кейс, что он невозможен.
Нет, мы просто покажем, что А квадрат не равно А.
А, ха-ха-ха-ха.
Когда А
Так,
квадрат не равно А, понятно, да? А
Да.
вдруг А
да.
квадрат равно А, он говорит, если все идеалы отличается невозможно. Теперь вот следующий показывает, рассматривает случаи, некоторые идеалы совпадают, да?
Ага.
Давай, продолжай. Сождем.
Now, suppose that for some I, the ideal AE coincides with A. That is A is equal to A. Then there exists an element A in the algebra A such that A EI is equal to EI. Okay? Uh, this contradiction A nilpotent. Tushunarlimi?
Evet.
Hmm, E.
Why A times A times E равно?
Okay?
Ovoz kelyapti.
Eshitilyaptimi, domla tovushim?
Ha, eshitilyapti. Mana bu nima uchun o'rinli deyapti anaqa?
Manavimi?
Srojednolik.
Yo, birinchi mana man chizganim. EI equal to EI. Why?
Biz mana shu yergacha kelib faraz qildikku, agar mana shu ideallarda biror biri A bilan ustma tushib qolmasa, u holda ziddiyat olib keldik. Endi faraz
Tushunarli.
qilyapmiz.
Siz bu yoqdan gapiring.
Ha,
Uni
shuni
tushundim.
qanaqadir
Hop,
qaysidir i uchun a yi teng a bo'lib qolsa, u holda
hop,
shuna a element topiladiki A'da. A
hop.
yi teng yi bo'ladi. Mana bu
Nimaga aynan YI boshqa YG, YK emas? YKga
E,
teng bo'lib qolmaydi.
sababi a y i qanaqadir i uchun a bilan o'smir tushgani uchun y i bu yerda ham borku, to'g'rimi?
Mana bu yerda ham EI bor-ku, mana shu.
Ha.
Yo, masalan, YIni boshqa YIga boshqa YKga o'tkazish ham mumkin-ku.
Yo, ular chiziqli erkli bo'lsa unday qila olmaydi.
Ha,
Yo, A bilan teng deyapti-ku.
ha.
Вот. А ей совпадает с А. Ей также является элементом А. То есть для любого элемента из правой части существует элемент из левой части, которые они равны, да?
Hmm. Ha, YI
Из,
bunda ham bor.
да, из
Bunday ham bor.
справа
Ha, bo'ldi.
берет элемент АИ. Значит, слева тоже есть элемент А. Она представляется как АЕИ.
Понятно.
Поэтому АЕИ равно ЕИ. Все уже АЕИ равно ЕИ. И так далее. ЕИ несколько раз умножает, все равно получается ЕА. Несколько раз А на А умножает, все равно получает ЕИ. То есть нипотентно. Не contradiction to the potency.
Because AKEI is equal to AE.
То
A
есть
element, nilpotent element,
element is
then
nilpotent.
hmm,
AN equal to 0
AE is
means
equal
the
to
left side
0.
is equal to 0, the right side is equal to EI.
Hmm.
This is
This
contradiction.
not because AE basis of A. So we always have A square subset of A. Hence, as shown above, the algebra A is nilpotent. Okay, the proof theorem. Proved theorem.
Okay.
Mm, Let I be right ideal of an algebra A. Show that if is nilpotent, then the ideal K is also nilpotent. Solution. Since A is nilpotent, there exists a positive integer m such that am is equal to 0. Let Z examination the powers of K. 0 cut square. This is A plus AI, A plus uh, I plus AI, subset of A multiplied A plus AI multiplied I plus I multiplied AI plus AI multiplied AI. Subset of uh, I square plus AI square. Okay?
Okay.
K square subset of I3 plus AI3. Uh, Proceeding in this way, they obtain the following.
Savol mümkün mü?
Huh?
Is it we must to prove in first time same also K is ideal
Uh,
in first step?
Any
So
element
no. Yes.
qanday idealligini demoqchimisiz, domla?
Yo'q, K'ni o'zini idealligini isbotlash kerak emasmi birinchi?
Endi isbotlash kerak. Endi uni isbotlamay o'tib ketdim. Osonroq biz osonroq deb.
Xo'p. Tushundim.
Lekin ideal bo'ladi. Tekshirib ko'rsa bo'ladi.
Ha, bo'ldi.
Yo, tekshirib Kdan ixtiyoriy element olaylik. Ana element olaylik. Ko'paytirilgan. B teng plus qanaqadir z ko'paytirilgan y ko'paytirilgan b x ko'paytirilgan b plus z ko'paytirilgan y b. Bu yana tegishli i plus a i ga. Xuddi shunday b ko'paytirilgan a ni ham shunga tegishli ekanini ko'rsatsa bo'ladi.
Davay o'sha ikkimisini ko'rsat, b ko'paytirilgan a ni.
B
Because in condition written E is only right ideal, but in the result written
ko'paytirilgan x plus
two-sided ideal. For that reason, is it so
b
trivial? I ask.
x plus bz. Okay.
Okay.
Yes, I understand.
From the fact that I is nilpotent, it's followed that K is nilpotent. Okay. Shall I continue?
Yes.
Let I be an ideal of an algebra A. Prove that any ideal of the question algebra A question I has the form J question A, where J is an ideal in A containing I. Uh, Let P with the natural homomorphism of from A to A quotient I. PA is equal to A plus I. Let J line be an ideal of A quotient I. Define J this proobras of J line. This set A in A where A plus I in J line. We first check that I subset of J. Since 0 plus I in J line and for any I in I, we have Pi is I plus katta A'da, katta i'da. This is belong in J line. It follows that E in J, this I subset of J. Next, prove that J is an ideal of A. If G1, G2 in J, then PG1, PG2 in J line. And therefore, Pj plus J2 is equal to Pj1 plus Pj2 is in J line because J line subspace of A quotient I. So J plus G2 in J. For lambda in K and J in J, we have P lambda J is equal to lambda P J in J line. Hence, lambda J in J. Finally, for any A in A and J in J, we have PAG, PA, PG in J line. PJA, PJ, PA in J line. Since J line is ideal of A quotient I, thus AG, JA in J, proving J is an ideal of A. It remains to show J line is J quotient I. By definition, J quotient I is J plus I, where J in J. This is Pj, J in J. By the construction Pj in J line for every J, and conversely, if A plus I in J line, then A in P minus 1 J line is equal to J. Hence, J line is equal to J quotient I. As a result, any ideal of quotient algebra A quotient I is a form J quotient I where J is an ideal of A containing I.
Okay. So next,
Hmm.
next problem.
Let A be an ideal of algebra A. Show that if the ideal A and the quotient algebra A quotient I are nilpotent, then the algebra I is also nilpotent.
Yeah, this
Solution.
problem is very important. if in ideal and the questions are nilpotent, we
Hmm?
we should show that I is nilpotent too. Yes.
Hmm.
Okay.
Assume I is nilpotent, so I power to the power of r is equal to 0 for some integer r greater than or equal to 1. And assume a question I is nilpotent, so I question I s is equal to 0 for some integer s. The condition equation I is equal to 0 means every product of S elements of A lines in A I. Because the question algebra equation I 0 element is A, I. Yani şu algebranın birlik nöl elementi bu i idealimiz. Where a to the power of n denotes the subspace generated by all products of n elements of A. Using associativity of multiplication, we have a to the power of SR is equal to a S R. Indeed, these generate by products of R elements of A to the power of S, each of which is itself a product of S elements of A. So such a product is a product of SR elements of A, and conversely, the products of SR elements we can group it into R blocks of size S. Now from AS subset of A, we get by I nilpotent ideal of A, then A to the power of SR is equal to 0. So A nilpotent of index at most SR.
Okay. The problem 3 is clear for everyone.
Özbekçe
Yes.
tushuntiramizmi domla?
Yo'q, hozir maqbol. Husanay,
Yes,
Nigora.
it was more easy for me, I think.
Ну, кто объяснит на русском языке? Заново.
Курсана.
Я
Husanay, да?
сейчас не могу.
Ну, давай.
Окей. Так, пусть и идеал алгебра А, и нам надо показать, что идеал И, вот, идеал И, тогда фактор алгебра АИ тоже будет нилпотентом. Если это нилпотент,
Если и фактор нильпотентна, тогда надо показать, что А тоже нильпотент.
будет нилпотентом. Представим, что И нилпотент, тогда это значит И в степени R равен нулю для
Да.
какого R больше единицы. И представим, что фактор по И тоже нилпотент. Это значит, что А по фактору И в степени S равен 0 для какого-то
Это
S.
все, все по условию, да, это все?
По
Да, это
определению,
все
по
по
условию,
условию.
да.
Не, это мы
Да.
представляем. По условиям
Да-да.
представляем.
Мгм.
Понятно.
Условия и фактор в степени S равен 0 значит, что каждое произведение, элемент S из А лежит в И, в идеале. Это означает, А в степени S принадлежит к И идеалу.
А вот это час самый важный час. Всем понятно, да, вот этот час?
Да, если
Почему
множество...
Да,
А степень
понятно.
S является подмножеством? Вот это час самый важный час. А здесь 0 был. А степени И S равно 0. Говорят, что из этого следует, что А степень S лежит в И. Вот это час. Всем понятно?
Вообще-то это другой ноль, да?
Это 0
Фактор.
Да.
фактор
О,
алгебры.
фактор алгебры. Это значит
Да, это значит 0
ноль
плюс
плюс
И, да,
и.
типа? Да,
Ноль плюс и,
поэтому А
да.
степени S лежит в
Да,
И.
для этого.
Понимаете?
Да.
Вот
Вот, это
самый
был
важный час вот
важный.
этот.
Это
Остальные
то,
все
что нужно
это
было.
сразу следует из этого, на самом деле. Дальше что, Хурсанай?
Так, вот где А в степени n, ну, отмечается как под пространством, ну, идеалом, обобщая все произведения элементов n из А. Используя ассоциативность умножения, мы имеем А в степени SR равен
Да, вот здесь
А в степени
тоже
S общее S.
ассоциативность важна. Если ассоциативность нет, то мы не можем получить вот это равенство. Здесь тоже ассоциативность
Да, да,
важна.
это по-другому будет, потому что если не будет ассоциативности, да?
Не имеем получить равенство, если ассоциативности нету. Дальше
Если
все
не
так,
будет.
как вот этот лежит в И, потом
Да.
вот этот лежит в И, а И степень R равно 0, поэтому А степень S равно 0, все. А нильпотент, так все.
А, да, сам по отдельности. Ну,
Да.
все. Да, понятно.
Всем понятно, да? Афпа,
Понятно. Понятно, понятно.
Мигада,
Да.
Фируза
Да,
точно здесь?
понятно. Да, понятно, да.
Все. Ладно, следующий. Next.
Mhm.
Сажда.
Next problem. Let A be finite dimensional nil algebra. Prove that the algebra A is nilpotent. Buni teoremani bir tarafi edi domla, buni ishlab ko'rsatishganini nima qilib o'tirmaymi? Mayli.
Ну, эту теорему вы же доказали же.
Уже сделали? А,
Boshqacha isbotlik. Mayli.
А?
Sal boshqacharoq yondashilgan, ya'ni o'sha e, a kvadrat a ga teng bo'lmagan holat bo'lmasligini oldin isbotlaganim uchun o'sha holatni tashlab ketib darrov isbotlayman. Bu ham shu teoremani isboti o'zi.
То же самое теорему будете доказать по-другому, да?
Hmm.
Associative algebra. Yes.
Hmm. Hmm. Ha, yes. E, Bu yerda ham shu a'ning o'lchamiga nisbatan induksiya qo'llaydi. Bir bo'lsa, ikki bo'lsa
In
to'g'riga
English,
qarab.
please.
Mhm. We proceed by induction of the dimension n of the algebra A. If base case, if dim A is equal to 1, then A is generated by a single element x which is nilpotent since A is nil algebra. That is, there exists k such that x to the power of k is equal to 0 because a nil algebra. Hence a nilpotent because the product of k elements all equals to x is 0. So the base case holds. Inductive step. Assume that any nil algebra of dimension less than a is nilpotent. Let dim a is equal to n. consider the ideal I is a square. Then I is not 2a equals 2a because a is finite dimensional and nil algebra. The ideal I is also nil algebra. Since A is nil algebra, its dimension less than of A dimension A. So by the induction hypothesis, I is a nilpotent. That is, there exists M such that Im is equal to 0. Okay? Consider the equation algebra A equation I. Since I is equal to A square, we have A equation I square is 0. Hence, A equation I is nilpotent equation algebra. By problem 3, we conclude that A algebra is nilpotent. Okay?
Okay.
By induction, every finite dimensional algebra is nilpotent. Problem 5. Let A and K be nilpotent ideal of algebra A. Prove that the ideal A plus K is nilpotent. Prove since A and K.
In this problem, you already proved. That's why you may left it.
Left nilpotent ideal.
Yeah, if A and K is the left important, you show that A plus K is left important. It's the same. Yes?
Next problem.
Mhm.
Prove that in a finite dimensional algebra, A, there exists a largest nilpotent ideal in A such that the quotient algebra contains no nilpotent ideals. Prove let A be finite dimensional algebra and let I1, I2, and so on, IK be all nilpotent ideals of A. For each ij, there exists nj such that ij nj is equal to 0. Consider ni. By the proposition, the sum of nilpotent ideals is again nilpotent ideal. Hence, Na is a nilpotent ideal. Moreover, since Na is the sum of all nilpotent ideals, it's the largest nilpotent ideal in A. Okay?
Okay.
Is this sum on simple sum or union, like said? What kind of sum? Qo'shish qanaqa? Oddiy qo'shishmi bu?
Ikkita idealda qo'shish bu
Ha,
mumkin
bo'ldi.
bo'lgan
I understand.
Yes, the sum of ideals.
I understand.
Now consider the quotient algebra. Suppose that n quotient n j quotient ni is a nilpotent ideal. Then j is a nilpotent ideal of n contained ni. But since ni is the largest nilpotent ideal, we must have j is equal to ni. Therefore, I quotient ni is contained non-zero nilpotent ideals. Because j's nilpotent ideals is 0 because ni zero element of quotient algebra of the quotient algebra. Okay, thus ni is the largest nilpotent ideal and a quotient ni has no nilpotent ideals. Ya'ni noldan farqli ideali bor deb faraz qilsak, u holda o'sha J idealimiz NA ni o'z ichiga oluvchi A ning ideali bo'lib qoladi.
J is nilpotent since by this some kind of proposition, yes,
Hmm.
which we prove.
Hmm.
Quotient algebra and NA nilpotent, it implies that same of the J also nilpotent.
Mhm.
I mean, it's not immediate, yes.
Tushunmadim Lola.
Mana bu Jni nilpotentligi to'g'ridan to'g'ri kelib chiqmaydi, to'g'rimi?
Endi J faktor NA buning nilpotent ideali degani buni nechidir marta ko'paytirsak o'ziga o'zini buning nol elementi paydo bo'ladi. Undan keyin NA nilpotent bo'lgani uchun uning nil indeksi bor. J ning qanaqadir darajasi NA ga qism bo'ladi. Keyin NA ning nilpotent
Shuni
indeksiga
isbotladik-ku tepada.
Evet, Başkan,
ha.
здесь вот это G, сумма нильпатентных идеалов же, поэтому G тоже нильпатентна.
Ha, понятно.
А, Просто
Понятно.
он хочет показать, что G это максимальный, который вот этот А фактор N не имеет нильпатентных идеалов. Вот это хочет доказать. G это нильпатентно, это понятно. Теперь надо доказать максимальность.
Понятно.
То есть larger nilpotent идеал. М? Дальше. Сложно.
Problem 7. Prov Z for any ideal of A is equal Ni is equal to I intersection Ni also. Let us first prove the following. I intersection Na subset of Ni. Take element X in I's intersection Na. Since A belongs to Ni, there exists an integer n such that xn is equal to 0 because Ni nilpotent ideal of A. As x in A, the element x is nilpotent also inside the subalgebra A. Hence, x in Ni. We now show that Ni subset of I intersection Na. Let y in Ni by definition y there exists m such that y to the power of m is equal to 0 in I. Since multiplication in I is a restriction of multiplication in A, the equality y to the power of m is equal to 0 holds in A as well. Therefore, y in Ni in A. Consequently, A in intersection Na. From the two equations we obtain this the following. Okay.
So, what was your last problem? So'radim.
Buni domla buni to'liq ishlashga ulgurmadim, lekin aniqrog'i to'liq ishlay olmadim.
An element A is called is idempotent if A square equal to A. And then
Hmm.
prove that N A, yeah, equal to this one, yes?
Hmm.
Mhm. Najma,
First of,
have you considered this problem or not? Did you try?
no, no, I have not tried.
Okay. Ну хорошо, что дальше тогда?
Mhm.
Все?
No?